morning, all of you children. Today we are going to discuss metals and non-metals lesson as part of our unit test 2 portion. You know that elements based on their physical and chemical properties, they can be classified broadly into two different categories: metals and non-metals. So other than these two, there are two more categories of elements. There are metalloids and anode gases. You know that metals. You are very well familiar with the physical properties of metals, that elements which are harder, which are having high tensile strength, which have high melting points and boiling points, which are excellent conductors of heat and electricity, are known as metals, and the elements that are having opposite characteristics to the characteristics just mentioned are referred to as non-metals. But basing on the chemical or electrochemical behavior, metals can be defined as an element that forms positive charged cations by losing one or more than one electrons are referred to as metals, whereas the elements that form negative charged anions by gaining one or more than one electrons are referred to as non-metals in general. So first let's go for metals. An element that form positive charged cation by losing one or more electrons is called metal. For example, sodium is a metallic atom as it loses an electron and forms Na plus N. Magnesium is a metal as it loses two electrons to form Mg2 plus. Aluminum is a metal as it loses three electrons to form Al3 plus cation. So some traditional metals will be that, as in the case of iron, it can lose two electrons to form Fe2 plus N. All these are metals as they are forming positive charged cations by losing one or more than one electron. Now let's have a look at the physical properties of metals. Physical properties of metals. So these are very well commonly known factors to you, these properties. Just while saying, you will be getting that, yeah, I knew it already. First characteristic of metal is metals are generally hot solids at room temperature due to strong metallic bonding forces of attraction operating in between metallic atoms. So in metal crystal, in between metallic atoms, strong metallic bonding forces of attraction will be operating. Due to these strong metallic bonding forces of attraction, metals generally exist as hard solids at room temperature. Metals are generally hard solids at room temperature. The exception will be there for this. You all know mercury is the metal existing in liquid state at room temperature. Mercury is the metal existing in liquid state at room temperature. Mercury exists as a liquid at room temperature. Then I said to you that metals are hard solids. Mercury is exception for this physical state, solid, that is existing as liquid, and I said to you that they exist as hard solids. If you consider sodium, potassium, calcium, barium, they are soft enough such that they can be easily cut with a knife. Sodium, potassium, calcium, and bearing are soft enough to be cut with a knife. Soft enough to be cut with a knife. So the first physical property of metal. Metals are generally hard solids at room temperature. For this exception will be mercury exists as a liquid at room temperature, and sodium, potassium, calcium and barium are soft metals such that they can be easily cut with a knife. That is the first physical property. Now coming to second property of metal, that is, due to strong metallic bonding forces of attraction operating, metals generally possess high tensile strength. That means metals can bear lots of stress and strain applied onto them without breaking up. That simply means that in our common terminology, when lots of stress and strain is applied onto metals, they don't break up, but they can bear that stress and strain applied onto them. That ability to bear lots of stress and strain without breaking up is known as tensile strength, and the tensile strength of metals is attributed to strong metallic bonding forces of attraction. That is, second physical characteristic is metals are highly tensile. That is, they can bear stress and strain. They can bear stress and strain without breaking. You know, metals are generally used for making metal sheets that are used for various purposes, and metal wires that are also used for various purposes. The ability by which a metal can be beaten into sheets or wires is due to the tensile strength of metals. But here also an exception is that metal zinc is a non-tensile metal. That means when force is applied onto zinc, it can't bear the stress or strain and it breaks into pieces. That is, zinc is a non-tensile metal. Exception: zinc is a non-tensile metal. So, due to this tensile strength, metals possess the properties of malleability and ductility. Malleability is nothing but tendency by which a metal can be beaten into thin sheets. Tendency by which a metal can be beaten into thin sheets. Metal can be beaten into thin sheets. So, the exception and it will be zinc. As it is non-tensile, it will not be malleable. Then fourth property is ductility. This is nothing but tendency by which a metal can be drawn into thin wires. Tendency by which a metal can be drawn into thin wires. Here for this also exception will be zinc, as it is non-tensile metal. So you will be getting it out. Sir, all the metals possess the same malleability or same ductility. It's not. They will be differing. So as far as the common metals we will be using in our day-to-day life, so the metal with highest ductility is gold. You will be surprised to know that 1 gram of gold, just 1 gram of gold can be drawn into a wire of length 2 kilometers. Sir, how is it possible? So you may be asking. That is to be done with an expert goldsmith. An expert goldsmith working with gold can draw that 1 gram of gold into a wire of length 2 kilometers. So you will be getting it out. So what are those wires are used for? Those gold wires are used for making expensive clothing. You know the gold zari saris, they used to say. When light is falling onto that, due to the presence of gold, it is appearing in brilliant, it is giving a brilliant shine to it. So, here one more property of metals is coming, that is, metals shine when freshly cut. That ability is known as luster and gem. Metals are lustrous. Metals are lustrous. That is, they exhibit a shining color when freshly cut. When freshly cut. For example, gold exhibit brilliant yellow color luster, silver exhibit brilliant white color luster, copper exhibit reddish brown color luster, iron will be exhibiting grayish white color luster in its pure state. So, this luster exhibited by metal is due to the availability of free electrons present in the outermost shell of the metal. Outermost shell of the metal is having some free electrons which are loosely held with nuclear forces of attraction. When freshly cut and when given polish, these electrons will get excited to higher energy levels, and those excited electrons will be jumping back to ground level by emitting that energy in the form of radiation, making metals lustrous. Then next property is metals generally have high melting point, that is Mp means melting point and Bp means boiling point. This high melting point and boiling point of metals is again due to strong metallic bonding forces of attraction operating in between metallic atoms. For these also some exceptions will be there. So first exception you will be getting it that mercury have very low melting point. Mercury has very low melting point of minus 39 degrees Celsius and boiling point of 357 degrees Celsius. That's why it exists as a liquid at room temperature due to its very low melting point, minus 39 degrees Celsius. It exists as liquid at room temperature, and when mercury is heated to a temperature of 357 degrees Celsius, it will be vaporized. Like if I consider gallium exists as solid at room temperature, but when it is taken to body temperature, that means when a small sample of gallium is taken into our palm, it will get converted into liquid state. That means at room temperature it exists as a solid, but at body temperature it will be converted to liquid. So gallium converts to liquid at body temperature. We all know that body temperature will be more than that of the room temperature. And another property of metals is that metals are sonorous. That means when struck with another surface, they produce a ringing sound. Metals are sonorous. This is about the physical properties of the metals, and based on this, by now you already got the physical properties of metals are determined by strong metallic bonding forces of attraction operating in between metallic atoms in a metal crystal. So now, coming to nonmetals, already I said to you, nonmetals are the elements that form negative charged anions by gaining one at more than one electrons. So, nonmetals, in between non-metallic atoms, weak forces of attraction are operating. These weak forces of attraction determine the physical characteristics of nonmetals. I think it's not needed to write it here, just metals characteristics, the opposite properties chooskunte, just they will be the properties of nonmetals. As in the case of metallic properties we are having exceptions, even in the case of nonmetals characteristics we will be having exceptions. First characteristics of nonmetals you say, nonmetals are generally soft solids, that means they can be broken down easily, or liquids or gases. Nonmetals generally exist as soft solids or liquids or gases. For example, if you consider sulfur, it's a soft solid. Iron, soft solid. Phosphorus, soft solid. Carbon in the form of graphite or coal, it's a soft solid. Sir, why did you say only graphite or coal? Why didn't you say diamond? Diamond is the hardest naturally occurring substance known to man. Why? Diamond is made up of carbon atoms. Carbon is a non-metal. Then it must be soft killer. Why it is hardest naturally occurring substance known to man ante? Diamond is the hardest naturally occurring substance known to man due to close and compact three-dimensional pattern of carbon atoms. That is an exception for that property. Second property చూసుకునేటప్పటికి non-metals are non-lustrous. As they don't have free electrons, non-metals do not exhibit a shining surface when freshly cut. For this also exceptions will be there. That is, graphite is having grayish black luster and iron is having greenish brown luster. Graphite grayish black luster and iron is having greenish brown luster. And non-metals are bad conductors of heat and electricity as they don't have free electrons. As they don't have free electrons, non-metals are bad conductors of heat and electricity. But graphite is a good conductor of electricity due to the fact that it is having one unpaired electron, or one free electron will be there in graphite. That's why it acts as good conductor of electricity. Generally, non-metals are having lower melting points and boiling points. Non-metals are having lower melting points and boiling points. Most of them exist as gases at room temperature. Hydrogen, nitrogen, oxygen, fluorine, chlorine, they are existing as gases at room temperature due to the low boiling points. But in the same way, if you consider diamond is the substance having highest boiling point, will be around some 3000 degrees Celsius to this part, melting point and boiling point. Again, it is due to close and compact pattern of carbon atoms in diamond. So like non-metals are non-lustrous, non-metals are non-sonorous. That means they don't produce a ringing sound when struck with any other object. Non-metals are neither malleable nor ductile as they don't possess tensile strength. As forces of attraction holding non-metallic atoms are weaker, they are non-tensile. That means they can't bear lots of stress and strain applied onto them. As they are non-tensile, non-metals will neither be malleable nor be ductile. These are the characteristics of non-metals. Coming to chemical properties of metals and non-metals. Metals generally react with acids, dilute acids, hydrochloric acid, sulfuric acid, dilute acids. Metals, when they react with dilute acids, they are associated with formation of salt and hydrogen gas. For example, metals react with dilute acids and form salt and hydrogen gas. You know that hydrogen gas puts off burning splinter with a pop sound. When a burning splinter is introduced, when hydrogen gas is releasing, that splinter was put off with a pop sound and gas burns with a blue flame. That gas is hydrogen. So, example, if you see Zn plus 2HCl gives rise to ZnCl2 plus H2. This hydrogen gas puts off burning splinter with a pop sound. Just like that, when magnesium metal is made to react with dilute sulfuric acid, it produces magnesium sulfate plus hydrogen gas. Here also, a gas that puts off burning splinter with a pop sound is produced. Just like that, when metals react with oxygen, they form metallic oxides. Metals on reacting with oxygen produces metallic oxide. Metals react with oxygen to produce metal oxide. These metal oxides, when they are added to water, metal oxide dissolves in water by chemically reacting with it, leading to the formation of metallic hydroxides, which are basic in nature. Metallic hydroxides are basic in nature. For example, if I consider magnesium metal, when it is heated in air, it combines with oxygen to produce magnesium oxide, which is a metallic oxide and which occurs in the form of a white ash. When this white ash of magnesium oxide is dissolved in water, it produces magnesium hydroxide. This is a base. How do you know that it is a base? When red litmus paper is inserted into the solution of magnesium hydroxide, it will be changed to blue in color. So substances that change the color of red litmus paper to blue are known as bases. Here, magnesium hydroxide changes the color of red litmus to blue, so I can say that magnesium hydroxide is basic in nature. Here, magnesium metal, when it is heated in air, it burns with a dazzling white flame. A brilliant white flame is given by magnesium when it is combined with oxygen, resulting in the formation of white ash of magnesium oxide. That magnesium oxide, when it is dissolved in water, is producing magnesium hydroxide, which is a base. So, next property, metals react with aqueous solution of some salts, resulting in displacement reaction. You know that chemical displacement reaction is a reaction in which a more reactive element displaces less reactive element and occupies its place to form a new compound. A highly reactive element displaces less reactive element from its compound, leading to the formation of a new compound is known as displacement reaction. So, several displacement reactions examples, if you see, iron metal, which is in grayish white color, when it is taken into aqueous solution of copper sulfate, which is in blue color, and if you leave the setup for some time without disturbing, after some time you can observe that blue color of the solution fades out and it will be changed to dull green color, and you can observe a reddish brown coating of copper onto that iron. So this is due to the formation of FeSO4 plus Cu. FeSO4 is in dull green color and copper is coated as reddish brown deposit onto that iron. Here what's happening is more reactive iron is displacing less reactive copper from copper sulfate and occupying its place to produce iron sulfate. Here copper is isolated. This is a characteristic redox reaction. From previous discussions you know that it's a redox reaction. Why? Because both oxidation and reduction are taking place. These are some physical chemical properties of metals. Coming to non-metals. Just like metals are reacting with oxygen to produce metal oxides, non-metals react with oxygen to produce non-metallic oxides. Non-metals react with oxygen to produce non-metallic oxides. These non-metallic oxides, when they are dissolved in water, they dissolve in water by chemically reacting with water, leading to the formation of acid. That's why I say that non-metallic oxides are acidic in nature in Japan. For example, if I consider sulfur, which is a non-metal that is existing as an yellow color solid, sulfur, when it is heated in oxygen, it burns with a burning smell of sulfur to produce sulfur dioxide. That sulfur dioxide, when it is dissolved in water, it produces sulfurous acid. As sulfur dioxide is dissolved in water to produce acid, I can say that sulfur dioxide is an acidic oxide. Just like that, oxide of carbon, CO2, on dissolving in water produces H2CO3, that is carbonic acid. So I can say that non-metallic oxides are generally acidic in nature, whereas metallic oxides are generally basic in nature. There is an important question with respect to state board. Describe an activity to show the acidic nature of non-metals and basic nature of metals in the question untundandi. So like this you have to write. Take a small magnesium ribbon, hold it with tongs and insert into the flame of Bunsen burner. You can observe it burns with a dazzling white flame. Lower the ash into test tube, add some water to that, shake the test tube such that ash gets dissolved in water. Pour 2 drops of the solution onto red litmus paper. You can observe that it changes to blue in color. So metallic oxides are basic in nature. Likewise for non-metallic oxides, take small quantity of sulfur in a deflagrating spoon. Deflagrating spoon is having long stem, and here material to be burned can be kept. So take small quantity of sulfur in a deflagrating spoon, introduced into the flame of Bunsen burner, then sulfur burns brightly. Now dip that deflagrating spoon into the gas jar containing oxygen. It burns, it continues to burn. It continues to burn, producing sulfur dioxide. Now add water into the gas jar. Sulfur dioxide reacts with water to produce sulfurous acid. Now pour 2 to 3 drops of the solution onto blue litmus paper. You can observe it turns to red in color. This is that activity. So you should read the textbook to get the clear picture of this lesson. Is that clear, Andy? Thank you all.